Another day, another Maker Advent, and today we have a continuation of the ESP32C3 Super Mini. Wow, that is a long thing to say. Project. So, started off with making it blink, getting it online. Making it blink proves that the GPIO works. Getting it online proves that we can use it online. So, I said we'd do a project to get it online, and I thought, okay, let's do one. So, I'm using ntfy.sh, which is something we used last year in Maker Advent with Node-RED. So ntfy.sh, I'll just bring up on screen now, there we go, is push notifications directly to your phone. There's an Android app, there's an app for Apple devices, you can get it on F-Droid as it says on the screen right now. It's got a really good API, it's free software, it works. I've used it on Picos, Pis, and now ESP32. I'm going to show you how to use it. So this setup right now is me, so you can see me when I press the button, so you know it's all real. Bottom left is my stunt phone, which is a spare old phone that's got ntfy.sh installed. I also have my real phone as well with ntfy.sh installed. That's my real phone. And I've got the code on the right hand side. I'm going to go through the code pretty quick. We've done a bit of it already in the previous example where I told you about how to get online. So let's crack on. We've got our import. So import network, get us online. From time import sleep, add pauses to the code, sleeps. From secrets, import style. Secrets is my secret file, which has the SSID and password for my Wi-Fi. And that's in the same location as this text file, which is the root of the ESP32C3. We've got from machine import pin, enabling us to use the GPIO. We've got uRequests, so micro requests as requests. So import uRequests as requests. Micro requests is just requests, but for microcontrollers. That's it. Requests is a way to push and pull messages around the internet using standard protocols. We've got a comment, get online. And this bit here, let's go from there actually. WLAN, the object, basically says, right, we're going to use networking. We're going to set it to active. We're going to scan for connections. It's going to show all the SSIDs. Then we're going to connect to our SSID, which is in secrets. So SSID, the AP of my Wi-Fi. Password, the password to connect. Sleep for 5 seconds. I always find that handy because it just allows the system to stabilize before we start saying, right, is it connected? And it'll print true or false. And then it's going to print the IP4 address. And it's going to show that we've got an IP address and we're online. Sometimes it comes back as 0. That still works, it's fine. It just means it's not been dished out a new IP address by the router. That's all. But first time it connects up, it'll just go, oh, right, okay, I'll give you an IP and you'll see the real IP. So I've got a button connected to GPIO pin 3. That's an input. And the internal resistor for that pin is pulled up. So it's 5 volts. So it's got a high signal to start with. So whenever we press the button, the other side of the button is connected to ground. And I'll put a schematic for this on the screen so you can see it all as well. While true loop. Okay, do this forever. If the value of the button goes to 0, so if the button's pressed, it connects the high side pin to ground, which pulls it low, so we get a 0. It prints in the REPL, which we never see, but it's there for debug, button pressed. Then using requests, it posts to notify.sh. So request.post, and then there's the notify.sh big Les doorbell. Yes, I expect people to use that and send me messages. Nice ones, please. Be nice. Data is just a message that we're going to send. And the answer is answer the door. Headers are the title of the message, so doorbell. Priority goes from 1 to 5, with 5 being the most high priority. And then tags is just so you can stick in emojis. I found putting more than 1 in, especially on ESP32, for some reason causes an error. So just stick to 1. So bell in this case. And I just close it down. Tell the code to sleep for half a second. And that's the if condition done. If the button's not pressed, it just prints button released, and sleeps for 0.2 of a second. That's it. So I'll put a diagram on the screen now so you can see how all this is wired up. It's simple, it's just 2 wires to a button, that's it. But I appreciate to everyone it's not simple because you've not done it before, so it's good to see a diagram. Okay, so now we go to the live demo bit. This is where it all goes crashingly wrong and I get egg on my face. I have 2 phones. That is what you're seeing on the screen. If I start moving stuff around, there you go. You can see it. And if I hold up the button to press it, there it is. I told you it was a simple setup. There's just 2 wires going to a button, that's it. Nothing at all. That yellow button is what kickstarts it all. So if I press the yellow button, 3, 2, 1. There we go. It's all blinking and making noises. If I press it again, there we go. We have an IoT doorbell from a, let's see, this was £6 for 3 of them, from a £2 ESP32C3 and a bit of wire. We can make it look pretty and we can use some arcade buttons. These have got LEDs built in as well, so we can have a bit of the script that flashes the LED about 3 or 4 times to say it's been pressed. Looks pretty. Also, you can waterproof it with an O-ring or something like that, or a grommet or what have you, and put it between the thread. Put it in something laser cut or 3D printed, stick it on the door. Now, obviously, this is not really an outdoor project unless you make it one yourself. Bit of hot glue, O-rings, rubber rings, that sort of thing will make it waterproof. But for something like a hack space inside a big building, you've got a doorbell. And everyone's phone who's got ntfy.sh installed will see the message pop up saying no to answer the door. So there's no more, oh, I never heard the door. Everyone's phone's going to go. So there we go. That is our ESP32C3 Super Mini IoT project. There's all the keywords for today. And that's it for now. See you later. Ooh, blurry. Ta-da.